July 1, 2025.
Astronomers across the world are quietly tracking an interstellar visitor, Comet 3I/Atlas, as it slips behind the Sun. These events are routine. We expect comets to vanish into solar glare, maybe emerge weaker or fragmented, but always alone. This time is different.
Mission logs flag something far stranger, a second signal trailing in its wake, as if something followed 3I/Atlas out of the Sun's shadow. Suddenly decades of cosmic surprises, Oumuamua's odd acceleration, Borisov's alien chemistry, Eson's dramatic breakup, seem tame. What exactly came out with 3I/Atlas?
And why do official data sets struggle to explain it?
The next 18 minutes will reveal what observers found, why the stakes could reach every corner of planetary science, and the unanswered questions still haunting experts today. A cluster of pixel-level anomalies flashes across archived frames from the Gemini North Observatory, timestamped to the second. The images, taken in slow in a prime band at 30-second intervals, show a sudden dip in brightness, then, in the very next frame, a faint trailing feature offset from the comet's expected path. Automated survey systems at Atlas in Chile and ZTF at Palomar flag the same sequence: a clean entry into the Sun's shadow, a sharp drop in signal, then a noisy, ambiguous cluster of pixels that triggers anomaly filters.
Every anomaly triggers a checklist.
Teams cross-check for cosmic rays, hot pixels, satellite streaks, known artifact patterns. Yet the disturbance persists across different telescopes, filters, and reduction pipelines.
This isn't just one observatory's blip.
It shows up in Atlas, in ZTF, and in Gemini's raw FITS files. The pattern is time-locked to the comet's reappearance from behind the Sun.
No single astronomer claims discovery.
Instead, the alert spreads through automated logs and internal mailing lists. NASA's JPL and ESA's Solar Orbiter teams both issue routine updates, noting the anomaly but withholding conclusion. Official Minor Planet Center circulars record only the comet's position and brightness, leaving the disturbance unaddressed.
In the absence of a clear explanation, speculation blooms.
Past comets have left similar puzzles: unexpected trails, sudden fades, debris clouds mistaken for companions. But this time the raw data is sharper, the timing more precise.
The anomaly sits on the edge of credibility, just enough signal to question, not enough to confirm.
Amid the uncertainty, the question grows louder: what, if anything, followed 3I/Atlas out of the Sun's shadow? For those tracking every frame, this isn't just an artifact. It's a call to look closer, to demand answers from the world's most advanced space telescopes.
Astronomers spot an object moving too fast for the Sun to hold it.
Later named Oumuamua, it entered from the direction of Lyra, spun erratically, and then vanished.
Its path didn't fit simple gravity. It seemed to accelerate as if pushed by an invisible hand.
Outgassing? Sunlight pressure? Or something stranger?
No one could agree.
Hubble and JWST, designed for deep imaging rather than rapid cadence, offer a different perspective. Their single-exposure frames capture the coma and tail structure in higher signal-to-noise but lack the movie-like sequence of the ground-based surveys. Mars orbiters watching from a different angle register only broad changes in brightness, not the pixel-level detail.
Across all these platforms, the moment of the brightness dip stands out.
Quick-look products and pipeline outputs flag the event for review. Every anomaly is checked against known artifact patterns, cosmic rays, hot pixels, satellite streaks.
Yet the disturbance persists, matching neither instrument signature nor random noise.
Official archives at Lab, Caltech, and the Minor Planet Center now host these frames for public scrutiny.
Each image can be traced to its origin.
For orbiting observers and ground teams alike, the images are more than data points.
They're a visual record of a mystery.
Past cases show how fragile such claims can be. A faint feature can vanish under a different filter, or reveal itself as a processing artifact when raw data is re-reduced. But if this trailing feature holds up under deeper analysis, especially spectroscopy, it could represent the first detection of material directly accompanying an interstellar comet out of perihelion. The logical next step is to move from raw images to spectral fingerprints, looking for clues in the light itself. Spectrographs come online within minutes of the brightness dip, pulling in every available photon as 3I/Atlas and its faint companion cross into view. Automated routines break down the incoming light into color bands, hunting for signatures that could reveal what, if anything, trailed the comet out of the sun's shadow. If a distinct spectrum emerges, different from the comet's coma or tail, that could confirm a real, physical object.
If not, the feature may dissolve back into the noise from which it came. Every new interstellar object is a messenger from another star system.
Even a tiny fragment or dust plume can tell us about the building blocks of worlds light years away.
Confirming a genuine companion would be like getting a second sample from the same cosmic laboratory. It would also challenge our models of how such objects survive close solar passes. Are they shedding material in unexpected ways?
Do they carry bound fragments? Could interstellar comets deliver complex chemistry, or even prebiotic compounds, into planetary systems they pass through? For now, the anomaly remains unresolved.
The images are public. The debate is live.
And as more frames are released and more eyes scan the archives, the search for patterns intensifies.
The next review cycle may bring clarity, or deepen the mystery. In the words of one astronomer, when a comet enters the sun's shadow, no one can predict what will come out. That uncertainty is the only guarantee. Drop your thoughts in the comments.
Subscribe and hit the bell to stay updated as new data and expert analysis arrive.
Because every time we think we've seen it all, the cosmos delivers another surprise.
Thank you for watching my channel.